number 20. In this class we will discuss the concept of route redistribution. So let's review the topology for this class. So we have routers R1 and R2. They are in area 0. So we are running OSPF on this interface and this interface. Okay. And there is a PC behind R1 Ethernet 12 interface which is in the network of 10.0.0/24. And on the other side R2 is connected to R3 and we are using BGP to send routing information. Then behind R3 we have PC2 with the 192.168.0.0 network. So in order to make communication work between PC1 and PC2, all the routers in the middle should be able to know the route for both networks. When the echo request is going out, all the routers need to know the route for 192.168.0.1, and same when the echo replay coming from the PC2, all the routers in the path need to know the route for 10.0.0. So I just configured the OSPF here and the BGP, but I did not add any network commands here to inject the routes into the BGP. So let's look at the routing table at this stage. So on R1 you see two connected routes, and in the configuration of the routing part you see there is only OSPF on R1 and it's running on only this interface because the network command we have given is matching with that only, so 12.12. Okay. And for the R2 we should see configuration for OSPF towards R1 and BGP towards R3. So currently it has only two connected routes, 12 and 23. And in BGP you can see the neighbor we have configured to R3 and we are not adding any networks into the BGP with the network statement. So then we have OSPF, and in the OSPF we are enabling it on the Ethernet 1 interface. On R3 we should only see BGP towards R2. So 23.23.1 remote AS2, this is towards R2 and we are not adding any networks into the BGP yet with the network statement. And R3 also knows about the connected routes only based on the interface configurations. So at this stage if we try to ping from PC1 to PC2 it will not work because the routers in between PC1 and PC2 does not know how to reach 10.9.192 network. So first I want to advertise this network to all the routers in this topology. So let's look at R1. R1 already knows this network because it has a connected interface. So there is no need to add any information or tell R1 how to reach PC1 because it already knows through the connected route. Then look at R2. So R2 is not directly connected to PC1. So but it has OSPF connection to R1. But as we only enabled OSPF on these two interfaces, OSPF will not advertise about this route because OSPF is not running on this interface. So one way to tell the route to R2 is we should enable the OSPF here. But if you don't want to enable OSPF here, the another way is we can tell OSPF that you can add the routes, connected routes. Whatever the routes you have connected, you can add it into the OSPF as an external route. So that is called redistribution. So here what we are trying to do is we are telling R1 OSPF process to add connected routes into OSPF. Okay. So for that we will go into the OSPF configuration and we type the command redistribute and what type of routes you want to add, whatever the connected routes this has. So whatever the connected routes, they will be added into OSPF as external routes. So once you do this command, this will become ASBR, okay, because it is injecting external routes. Then it will generate type 4 and 5 SLAs as we discussed in the previous classes, and then these updates will reach the R2. So once you do this command, you should be able to see routing table on R2 for this network. So here is the output. On R2, when I do show IP route, you can see now there is a OSPF route and external route popped up, and it is pointing towards the correct direction, 12.12.1, this way. Okay. So route redistribution is injecting routes from one routing source to another routing source. In this case, we are adding connected routes to OSPF. So now R1 and R2 knows about this network. Now we need to tell R3 about this network. So currently there is BGP between R2 and R3, but we didn't. The one way we can advertise the routes from R2 to R3 is you can use the network command. If you do network command and 10.0.0.0.0, it will start advertising it to R3, but we didn't add any network command yet, and we don't want to add it because this is not feasible if you have thousands of routes you are learning from OSPF, right? For each network you need to add the network command. So that is not feasible in the production environments, because where you will have hundreds of routes coming from OSPF. So the easy way to redistribute those routes from OSPF to BGP is go to the BGP configuration and we tell BGP to get the routes whatever OSPF learned, and in this case I only want to inject the routes, external routes only, not OSPF routes, the internal routes, because I don't want to advertise this network yet. Okay, so we are just working on making communication between PC1 and PC2, so I just only want to advertise this 10 network. So this 10 network is advertised into OSPF as an external one, so that's why I'm using the command redistribute OSPF match external. So whatever the routes R2 learned through the OSPF external SLA, they will be added into the BGP. So once they are in the BGP, they will be advertised to the R3. Okay, so here we are using redistribution instead of the network command. So if we go to R3 now, we should be able to see the BGP route. So BGP, eBGP, and we see 10 network is here, and the next hop is 23.23.1. So this is correct. So this way echo request can now go from PC1 to PC2, because R1 knows about 10 network, R2 knows about 10 network, R3 knows about, oh sorry, this is for the replay packet. So when the PC2 replays, all the routers will know the destination IP, how to forward routing information for the destination IP. Okay, just ignore this part. So when PC2 replying back, the destination IP will be 10.0.0.1, right? So now all the routers in the path will know how to send the packet to destination IP, which is 10.0.0.1. So now let's look into the original direction, echo request PC1 to PC2. So when PC1 sending echo request to PC2, the destination IP is 192.168.0.1. So now all the routers in the middle should be able to know the routing information for this IP. Okay, so let's come from this side, because always routing updates comes from where the network is, right? So on R3 we have BGP session. R3 knows about this network because it is connected, so no need to tell R3 how to reach this network. Then this is covered. And what about R2? R2 now does not know anything about this network. So how we can tell R2 about this network is we already have BGP, right? So now from R3 we can tell R2 using BGP how to reach this network. So for that we can use the network command, but we are using redistribute. So what we want to redistribute on R3, whatever the connected routes you have, redistribute them into BGP. So this connected route redistribute into BGP. For that you will go to the router BGP configuration and then tell the BGP to get the routes whatever you have learned through the connected source, redistribute connected. Now R3 will advertise that route with BGP to R2. So on R2 now you can see there is a BGP route, external BGP, and about 192.168 network via 23.23.2. Okay, so then this is also covered. Now we need to tell R1 how to reach 192.168 network. So R2 learned about, so R3 advertised 192 network using BGP. So now R2 knows how to reach 192 from the BGP route. Now it needs to tell R1 about that route, but it has OSPF. So in this case what we need to do is whatever the routes you learn from BGP, redistribute into OSPF. That means in the configuration we need to tell R2 that under the OSPF configuration redistribute BGP routes. So we go into the R2's router OSPF process and we tell R2 OSPF to add whatever the routes you are learning from BGP into OSPF. Okay, so now what will happen is we are redistributing BGP routes into OSPF so that whenever we do this command it should generate external LSAs from R2 and they should be going into this area. We should reach R1. Okay, so now you should expect OSPF external route on R1 for 192 network. So this way as the next hop. Okay, so now when we try to send a packet from PC1 to PC2, every router in the middle knows how to reach this. So echo request will work with the destination IP of 192.168.0.0. So let's see the routing table as a whole now. So when we are sending echo request, the destination IP is 192. So let's see, we have the routes on R1 and R2 and R3. R1 knows 192, it learned through OSPF external 2, and R2 knows 192.168 from BGP from R3, and R3 knows about that as a connected route. Okay, so for this echo request to work, what we did is we redistributed connected routes into BGP, then R2 redistributed BGP routes into OSPF. So that's how all the routers in the middle able to know about this network. Now let's look at the return packet. This will be echo reply. The destination IP of the packet is 10.0.0.1. So let's see how R3 knows about 10 network. It knows from BGP, so it is learning from here. Next, look at R2. How R2 learned about this through OSPF external. So from here to here the routing update happened. From R1 advertise it to R2 as external. That means it was not part of the OSPF because we used the redistribute connected command. Okay, and R1 knows about this because it's a connected interface, so that the return packet from PC2 to PC1 will come. So assignment for this lab is build the same topology and do the same configuration for the redistribution and verify the route tables on all the routers and verify OSPF database on these two and verify what routes you are advertising using the show IP, BGP, neighbor IP, and the advertised and received routes on both before redistribution and after redistribution. Same things for OSPF database comments before and after then you will be able to see the difference, what's happening, and how the redistribution is working. Yeah, that's all for today's class.